Today's lesson is on chapter 3.6 and 3.7. Let's begin by recalling what we learned last class. We learned about collecting like terms, and like terms are terms that have the same variables and exponents. An example is shown here. Our first step is to collect like terms. Then we can simplify like terms. Let's move on to today's lesson, adding polynomials. To add polynomials, remove the brackets and collect like terms. A polynomial is in its simplest form when it contains no like terms. We're going to practice adding polynomials. So the polynomials are inside brackets right now. And so we need to expand out of the brackets by removing the brackets. Okay, so when you're adding polynomials, what we're doing is we're just writing the polynomial as it is without brackets. Then you're going to collect like terms. And then finally, you're going to simplify like terms. Next example, we're going to expand out of the brackets by rewriting all of our terms without brackets. Then we will collect like terms. And then we will simplify like terms. See? Remember to order terms chronologically, beginning with the highest exponent and ending with your constant term. And the last example. Next page, we're going to practice some word problems. A rectangle has length 4x plus 1 and width x plus 2. Write a simplified expression for the perimeter of the rectangle. In order for us to visualize this rectangle, I'm going to draw it out first. So in the question, it says that the length is 4x plus 1. So instead of writing L for length, I'm going to write 4x plus 1. And then the width is x plus 2. So instead of writing W for width, I'm going to write x plus 2. And we know that perimeter is adding up all the sides. So our perimeter is equal to x plus 2 plus x plus 2 plus 4x plus 1 plus 4x plus 1. Let's expand out of the brackets. And collect like terms. And then simplify like terms. Okay, so that's the simplified expression for the perimeter of the rectangle. Part B, find the perimeter of the rectangle when x is equal to 5. I'm going to begin by writing our simplified expression for perimeter. And then I'm going to substitute 5 for x. Therefore, the perimeter of the rectangle is 56 units. This question doesn't actually give us the units, so I'm just going to write units because I know that my perimeter needs to have some sort of unit. So when it's not given to me, I'm just going to write units. Example 3. A local food bank buys from food wholesalers to save money. The table below shows how much it costs to buy food from the wholesalers. So there's 3 wholesalers here. Okay, so just reading this, the first one, homegrown produce, they have a fixed price of $110. So no matter how much is purchased, they're going to charge $110. And then there's an additional fee, $5 per kilogram, which is represented by 5K, 5 times number of kilograms. Next, baked goods charges a fixed price of $200. And this dash just means that they don't have an additional fee. So it's just $200 every time you buy from baked goods. And finally, Meats and Alternatives Limited. They have a fixed price of $60. So this company charges a significantly less fixed price than the other companies, but their additional fee per kilogram is significantly more at $50 a kilogram. In part A, write an expression that represents the total cost for buying food from each wholesaler. Let's begin with homegrown produce. A simplified expression would be 5K plus 110. Next, baked goods is equal to $200. And finally, Meats and Alternatives Limited is equal to 50K plus 60. Part B. Write a simplified expression for the total amount paid to the wholesaler food companies, assuming the food bank orders the same amount of food from each wholesaler. So the total is equal to 5K plus 110 plus 200 plus 50K plus 60. Expanding out of the brackets, collecting like terms. And then simplifying like terms. There are some homework questions for chapter 3.6. Please pause the video now and complete these questions, and then resume watching 3.7. Chapter 3.7, the distributive property. The distributive property allows you to expand algebraic expressions. When distributing, multiply the monomial by each term in the polynomial, multiply numerical coefficients, and apply exponent laws to variables. The distributive property helps us expand out of the brackets correctly. In 3.6, the coefficient in front of the brackets was always 1. So when you're multiplying 1 times anything inside the brackets, it won't change the value of any terms in the brackets. But what if the coefficient a is another value other than 1? Then you have to multiply that coefficient by all of the terms inside the bracket. So a times x, and then a times y. Let's practice in these examples below. So we have coefficient 3 in front of the brackets, which means that we're multiplying 3 by the polynomial inside the brackets. So 3 times x and 3 times 2. So 3 times x is 3x, and 3 times 2 is 6. Next, we have -5 in front of the brackets. The negative is part of the coefficient. So we're not going to multiply the polynomial by 5, we're going to multiply it by -5. So -5 times 4m, and then -5 times -3. This negative belongs to 3. -5 times 4m, we're going to multiply the coefficients together. So -5 times 4 is -20. And then we're going to include the m. Let's look at that on the side here. -5 times 4m. The coefficients are going to be multiplied by each other. -5 is a constant. It does not have a variable in that term. But 4n has variable n. We can pretend that there is an invisible 1 beside the constant 5 to represent a variable that doesn't exist there, and we can multiply that 1 by m. So 1 times m is m. Moving on, -5 times -3. Negative and a negative make a positive. 5 times 3 is 15. C. X times x minus 3. So x and x are going to multiply together. X times x is equal to x squared. Remember your exponent laws. The bases are the same, they're x, and they both have an invisible exponent 1, so you add the exponents, and that results to x squared. And then x times -3 is -3x. So this x has an invisible coefficient 1 in front of it. So that invisible 1 is being multiplied by -3. So that's how we get our -3 value. And then -3 is a constant. It doesn't have a variable, but the x term does, and that's where this x variable comes from. We can't simplify any further because x squared and x terms are not like. Moving on, we have to multiply p by p squared, -2p, and +1. So p times p squared is p cubed. Subtract 2p squared plus p. We don't need to write 1p, we just write p. We can't simplify this any further because none of these terms are like. Next, this is just using the distributive property in the opposite way. So the coefficient is on this side of the polynomial. We still have to multiply it by both terms inside the polynomial. Finally, 2 times 5a squared, 2 times -7a, 2 times 2. 10a squared, subtract 14a plus 4. The distributive property can be applied to polynomials with any number of terms. The distributive property allows you to simplify complicated expressions. In example 2, we're going to subtract polynomials using the distributive property. When polynomials are separated by a subtraction sign, we understand that there is an invisible 1 in front of the negative sign. So really this is -1 times 1 subtract x. This one is also -1. Now in front of the first polynomial, this is just a +1. We completed distributing out of the brackets for polynomials with coefficients that were +1 back in chapter 3.6. So when you distribute out of this bracket, nothing changes. The terms don't change. 1 times x is still x, 1 times 2 is still 2. So you're just going to write all the terms without the brackets, as is. But when you're multiplying by -1, that is going to change the signs of the terms inside the brackets. My next line, I'm going to remove all of the brackets by using the distributive property. Since my coefficient for polynomial 1 is 1, I'm just going to rewrite all the terms inside the bracket without the bracket. -1 times 1 is -1, and -1 times -x is +x. The terms inside the second brackets, they just switch their signs to its opposite. And that will happen as well for the third polynomial. Next, let's collect like terms. And finally, we can simplify like terms. X plus x minus x. So these two x's are going to cancel each other out. So I'm left with just x. And then 2 minus 1 minus 8 is -7. Next question. The first polynomial is being multiplied by +1. So distributing that out of the brackets, it's going to stay exactly the same. Next polynomial is being multiplied by -1, which means distributing out of the bracket, these signs will just change to its opposite. And lastly, none of these signs will change. Collecting like terms. And then simplifying like terms. And that's it. Last page. Expand and simplify. So the coefficients in front of the polynomials are various values. But we're still going to multiply the coefficient by all the terms inside the brackets. For some reason, when I converted this Google Doc into a PDF, question D moved down a line and is now in front of question C. Your version should not look like this. I'm just going to rewrite question D where it should be written. In question C, we're multiplying it by a fraction. To make this easier to multiply, I'm going to make all these whole values fractions. And remember that all whole values have an invisible denominator of 1. So now it's easier for us to multiply the numerators together and then the denominators together. And then these 2's will cancel out. So we're left with W, subtract 6 divided by 2 is 3, subtract 18 divided by 3 is 6W, and then plus 4. Collecting like terms. And then simplifying like terms. Next, 14x squared times 3x. So I'm going to multiply my coefficients together and then remembering exponent laws, multiplying my variables together. 4x squared subtract 5 is negative 20x squared. Subtract 3x cubed plus 9x squared, subtract 3x plus 16x, subtract 16. Collecting like terms. And then simplifying like terms. Example 4. In this example, we have two sets of brackets. We're going to distribute the inner brackets first and then make our way out. So the coefficient 3 we will leave as is. Bracket, the 2 will stay as is. 5 times 2k is 10k, and 5 times negative 11 is negative 55. Next, I'm going to simplify inside the brackets before distributing the coefficient 3. I'm going to collect like terms in the brackets and then simplifying like terms in the brackets. And now I'm going to distribute the 3. Okay, last question. A field has the following dimensions. Write an expanded expression for the area of the field. Okay, so remember this is your length and this is your width. We know that area is equal to length times width. So instead of L and W, I'm going to sub in 4x plus 3 and 3x. Now I'm going to use the distributive property to expand out of the brackets. I can't simplify any further because these terms are not like. Finally, there are some practice questions from chapter 3.7 for you to complete, and of course, completing today's quiz. Join our Zoom or message me if you have any questions.